The success of any instrumental analysis depends on maintaining your system in a state of peak performance. In the previous TA Tech tip, we addressed the baseline verification. Now we'll focus our attention on the calorimetry and the temperature measurement, and specifically how to verify that your TA Instruments DSC is providing you the highest quality data in terms of heat flow and temperature. The first step to verifying your DSC calorimetric performance is to analyze a known standard. Now, there are many standards available which are well documented as reference materials for both temperature and enthalpy calibration. The most common material used for DSC calibration is indium. Here we see a DSC scan of indium metal analyzed at 10 degrees per minute. Make sure the data is scaled so that you can determine the baseline on each side of the indium melting peak. Then use the peak integration function to calculate the peak area and onset temperature for the melting transition. The literature value for the indium heat diffusion is 28.71 joules per gram. Your measured value should be very close to this. Your own laboratory standard operating procedure should determine your error tolerance and when you need to recalibrate. For example, you might determine if the measured value is more than 3% in error, then recalibration is required. As enthalpy is strongly dependent on the measured mass of the sample, TA Instruments generally does not provide a calorimetric accuracy specification. This same data can be used to verify the temperature accuracy. Compare the measured onset temperature to the theoretical value of 156.6 degrees Celsius. Again, your need to recalibrate will depend on your lab's standard procedure, but in general, a Q2000 DSC can maintain accuracy to within about plus or minus 0.1 degrees C. If necessary, you can use other melting standards to verify temperature and enthalpy accuracy across a wide range of temperatures. This table shows some of the typical standards used for DSC. You may want to verify the performance across a range of heating rates as well. TA Instruments DSCs measure the sample temperature directly and as such do not require a heating rate dependent calibration. This can be verified by analyzing a sample of indium at several different heating rates, such as 1, 2, 5, and 10 degrees per minute. For the Q2000 and Discovery DSC, the measured onset temperature is accurate to within plus or minus 0.1 degrees C under all conditions. A plot of onset temperature versus heating rate demonstrates this temperature accuracy as well. The combination of the baseline verification, along with the cell constant and temperature measurement verification, guarantee that your TA Instruments DSC is providing you peak analytical performance.